continue our class for topic 3, which is reaction of alkene. So in this subtopic, we will learn about reaction of alkene. So for this code, we cover for about 2, 4, 6, 7 reaction of alkene, which are hydrogenation, addition of HX, addition of X2, addition of H2O, epoxide formation, ozonolysis, and the last one is hydroxylation. So please take a look of hydrogenation first. Okay, what is hydrogenation? So for the hydrogenation, it state here hydrogen. So means that it use hydrogen in its reaction. For example, here you have 1, 2, 3, 4, 1, 2, 2, butane. In the present, when it state here hydrogen, so you will use hydrogen. In the present of platinum or palladium or nickel, you can use either one, but you cannot use both. You can choose either platinum, palladium or nickel. So basically this reaction is addition reaction, means that you add hydrogen at unsaturated part, which is here we call as unsaturated part. So you add hydrogen here. So at the end of the reaction, so you will get this is the hydrogen that you add, or we assume like this. So you will produce a butane or alkene. And for addition of HX, so it involves addition reaction. What is X? X can be chlorine or bromine. So here you use hydrogen, highlight that you use are referring to this chlorine and bromine. So the reaction involved, for example, you have butane here, 1, 2, 3, 4. So HBr in the present of acetic acid. So at the end of the reaction, you will get, so here you add HOBr here, you will get alkyl halide. Here we call as a symmetrical alkene because the number of hydrogen here is 1 and here also 1. What happens if you have an alkene which is categorized as unsymmetrical? This is symmetrical alkene. When we call as unsymmetrical alkene, let's say double bond here. So as you can see here, because here is invisible, but I want to show you the number of hydrogen here should be Here is 2 hydrogen. At this carbon, you have 1 hydrogen. So what happened here is you need to follow this rule. We call this rule as Markovnikov rule. Markovnikov is a scientist from Russia. So what's Markovnikov rule state? Markovnikov rule state that Br or halogen group will add to the carbon that has lowest number of hydrogen, which is here, while hydrogen will add to the carbon that has highest number of hydrogen. So in this case, so you will add hydrogen here. You will add hydrogen here, and at the same time you add bromine here, because this carbon contain less hydrogen. So bromine and hydrogen. And what about if you saw this rule we call as Anti-Machovnikov Rule? What is Anti-Machovnikov Rule? Anti-Machovnikov Rule state that oppositely, means that hydrogen will add to the carbon that has less hydrogen, while halogen group will add to the carbon that has more hydrogen. It is opposite to the Markovnikov rule. Okay, for example here. But how to differentiate between the Markovnikov? When you will ask me, madam, when we will follow Markovnikov rule or when we will follow Anti-Machovnikov rule? So when you will follow the Markovnikov rule, if you use here peroxide condition, the condition is in peroxide, or you will see this symbol ROOR. ROOR is representing peroxide. Peroxide will make the addition of HX follow Markovnikov rule. So it will be here is Br and here is H and H. Okay. And then for that is addition of HX. How about addition of X2? Addition of X2. X representing Cl or Br. So in this case, X2 is Cl2 or Br2. So for this kind of reaction, we do not follow Markovnikov rule. We just 1, 2, 3, 4, 5. Here we have 2 pentene. So you just add halogen at unsaturated part. Add the carbon-carbon double bond. So Cl2 in the presence of CCl4. Here will act as solvent. You can use CCl4 or CH2 Cl2. So the addition is we call as a trans addition. Means that Br will add to the carbon-carbon double bond, but the configuration of Br is one is up, one is down. In trans configuration, or you can draw like this. Here is representing up, here is representing down. So representing trans configuration. Then for addition of H2O, so addition of H2O, you will use H2O in the presence of H2O, the region H2O in the presence of acid that act as catalyst. So you have here okay, 1, 2, 3, 4, 5, 2-methyl pentene. 1, 2, 3, 4, 5. Okay. So in the presence of, you react with H2O in the condition of acidic condition. You use strong acid here, which is sulfuric acid. So this rule, this addition of H2O, it will follow Markovnikov rule. So do you still remember what Markovnikov rule state? Markovnikov rule state that in this case you have H2O, right? So we can divide into OH and H. So OH will add to the carbon double bond, or to the carbon that has lowest number of hydrogen, while hydrogen no, here should be here. So hydrogen will add to hydroxide, OH will add to the carbon that has lowest number of hydrogen, while hydrogen will add to the carbon that has more hydrogen. So if you can see here, there is no hydrogen here because the bond is already complete 4 bond, while here you have another one hydrogen. So means that this carbon has more hydrogen atom compared to this one. So at this carbon we add hydrogen, and at this carbon we add OH. Okay. And for the epoxide formation, epoxide formation normally produce two membered ring. So if you use ethene as your starting material in the presence of oxygen, the condition silver will act as a catalyst at condition temperature around 250 degrees C. So this bond will break, then you will produce an epoxide. Okay, this we call as epoxide formation. Okay, what is ozonolysis? Ozonolysis is another type of reaction of alkene, which is you react with ozone in the presence of zinc as a catalyst. and in acidic condition. So let's say you have here CH3, CH2, CH3, and here is double bond CH2. Okay, so you react with ozone in the presence of zinc in acid condition. So what happened here? Double bond, what is the function of oxygen here? So the oxygen will cleave the double bond and zinc will accelerate the reaction. And what happened here is it will produce CH3, CH2, C, and here is CH3. At the cleave side, you just add double bond O plus here double bond O and then CH2. Means that here you will produce a ketone and here you will produce aldehyde. Okay. And finally, the hydroxylation reaction. Hydroxylation reaction. Here is hydroxylation reaction is another type of reaction of alkene. For example, here okay, react with KMnNO4 potassium permanganate in basic condition diluted, and you need to put cold. Cold means that at room temperature. So you will produce OH will add at the carbon-carbon double bond with cis addition. Means that OH will be at the same side of carbon-carbon double bond. Okay. Finally, actually we have two tests to distinguish between alkene and alkane. So between here is we call as bromine test, and then here is Bayer test. So bromine test will use bromine as reagent, bromine, diluted bromine, and Bayer test you will use KMnO4. So KMnO4 in the presence of water which is in dilute condition like this, and in basic condition and at room temperature cold. So what happened here, for example, here you have alkane, here is alkene, here is single bond, here is double bond. So for bromine test, bromine color, what is your observation? Bromine color remain unchanged. For alkene, bromine color turn to colorless. And here for Bayer test, purple permanganate solution, purple color of permanganate solution remain unchanged. And for alkene, purple color of permanganate turns to colorless. Okay, basically this is the two tests. This test is very easy one, and turn to colorless, and at the same time brown precipitate observe at the bottom of the test tube. So normally you will use bromine test or Bayer test to differentiate between an alkane and also alkene. And finally, for the uses of alkene. So what is the uses? Basic use of alkene. So normally in our life, alkene can be used in the production of PVC pipe and polystyrene, food packaging, here is polypropylene, food container, and also PET, polyethylene, bottle, what we call as PET, polyethylene bottle. This is the basic application of alkene in our life.